German vehicle arrived at Aberdeen Proving Ground in the spring of 1943, strapped to a flatbed trailer and covered in canvas. The American officers who gathered to examine it expected to find advanced engineering, superior metallurgy, or some technological secret that explained why German armor was destroying Allied tanks across North Africa and Europe. Instead, they found a machine that looked like someone had forgotten to finish building it. The StuG III had no turret. The main gun was mounted directly in the hull, fixed forward, unable to traverse without turning the entire vehicle. The armor was no thicker than what protected an American Sherman. The engine was actually weaker than American power plants. By every metric the Americans used to evaluate tanks, the StuG should have been inferior. But the kill ratios told a different story. German assault gun units equipped with StuGs were destroying Allied armor at rates of 5-to-1. Sherman crews were dying in machines that cost more to build, carried more armor, and mounted guns that should have been equally deadly. Something was wrong with the American understanding of armored warfare. The Aberdeen tests were designed to find out what. The officers who organized the trials approached the problem scientifically. They would stage controlled engagements between the captured StuG and American Shermans, measuring every variable that might explain the German vehicle's battlefield success. Time to acquire targets, accuracy of first shots, vulnerability to return fire, crew survivability. What they discovered would force the United States Army to rewrite its tactical manuals before the invasion of Normandy. The first test measured target acquisition. A Sherman and the StuG were positioned at combat distance, approximately 800 yards apart, with both crews ordered to spot the enemy vehicle as quickly as possible. The crews were matched for experience. The conditions were identical. The only variable was the vehicle itself. The Sherman crew spotted the StuG in an average of 14 seconds. The StuG crew spotted the Sherman in an average of 3 seconds. The officers ran the test again and again. 12 controlled duels between the two vehicles. In 10 of those duels, the StuG crew identified the Sherman first. In only 2 did the Sherman crew manage to spot the German vehicle before being spotted themselves. The difference was 58 centimeters. The StuG III stood approximately 2.16 meters tall from the ground to the top of its superstructure. The Sherman M4 stood approximately 2.74 meters tall. The difference, 58 centimeters, roughly 2 feet, seemed insignificant on paper. In combat, it was the difference between life and death. The physics were simple and brutal. A lower vehicle presents a smaller visual target against the horizon. When positioned behind a fold in the terrain, a ridge, a hedgerow, or any other partial cover, the lower vehicle can expose only its gun while keeping the bulk of its mass hidden. The taller vehicle must expose more of itself to achieve the same firing position. More importantly, the human eye is naturally drawn to vertical shapes against horizontal landscapes. A tall tank silhouetted against the sky is visible from miles away. A squat assault gun, pressed close to the earth, blends into the terrain. The StuG didn't need to hide. It simply needed to be low, and the physics of visual perception did the rest. The Aberdeen tests continued with accuracy measurements. Both vehicles were given identical firing scenarios, engaging stationary targets at various ranges. The results were comparable. Neither crew demonstrated significant superiority in marksmanship, but accuracy didn't matter if you couldn't see your target. The StuG crews in combat didn't win because they shot better. They won because they shot first. By the time a Sherman commander identified the German vehicle and ordered his gunner to engage, the StuG had already fired. The first round was typically lethal. The duel was over before the Sherman crew understood it had begun. The American officers began to understand something that German designers had grasped years earlier. Armor thickness was a secondary consideration in tank warfare. The primary consideration was visibility. A tank that couldn't be seen couldn't be hit. A tank that couldn't be hit didn't need thick armor. The Germans had built the StuG with just enough protection to stop infantry anti-tank weapons and shrapnel, then invested the saved weight in a lower profile and better gun. The Americans had built the Sherman with more armor, a taller turret, and worse survivability. The mathematics were counterintuitive but undeniable. The Sherman's extra armor made it more visible, which made it more likely to be engaged, which made it more likely to be destroyed. The armor that was supposed to protect the crew was actually getting them killed. The StuG III had started life as an infantry support vehicle, not a tank destroyer. Ferdinand Porsche had designed it in 1937 as a mobile artillery piece that could accompany infantry assaults and destroy fortifications. The low profile was originally intended to make the vehicle easier to conceal during infantry operations, not to create advantages in tank versus tank combat. The tank-killing role emerged accidentally. When German forces encountered Soviet armor in 1941, they discovered that the StuG 75 mm gun could penetrate enemy tanks just as effectively as dedicated tank destroyers. More importantly, they discovered that Soviet tank crews had enormous difficulty spotting the low-slung assault guns before they opened fire. The weapon designed to support infantry was massacring enemy armor. The German military recognized the pattern and began deploying StuGs specifically for anti-tank operations. By 1943, StuG units had destroyed more enemy vehicles than any other type of German armored vehicle. The ugly, turretless machine that looked like an unfinished tank had become the deadliest weapon in the Wehrmacht's arsenal. The Americans at Aberdeen were late to understanding this lesson, but they learned it thoroughly. The test reports documented everything: the engagement distances at which each vehicle became visible, the angles of approach that maximized concealment, the terrain types that favored low-profile vehicles versus tall-profile vehicles, the statistical probability of survival based solely on the moment of first detection. The conclusions were damning for American tank design philosophy. The Sherman had been built with a tall turret because American doctrine emphasized all-around capability. The rotating turret allowed the gunner to engage targets from any direction without repositioning the entire vehicle. It was a flexible design that worked well in mobile warfare. But the tall turret made the Sherman visible, and visibility, the tests confirmed, was more dangerous than any deficiency in armor or firepower. The reports went up the chain of command. Officers who had spent careers advocating for heavier armor and bigger guns were confronted with data suggesting they had been solving the wrong problem. The enemy wasn't winning because their tanks were tougher. They were winning because their tanks were harder to see. The tactical manuals were rewritten before D-Day. American tank commanders received new training that emphasized hull-down positions, terrain masking, and the use of natural concealment. They were taught to think about their silhouette the same way infantry thought about their exposure to fire. The lessons that German assault gun crews had learned through years of combat were compressed into briefings delivered in the months before the Normandy invasion. The changes saved lives. Not as many as they should have, because the fundamental design of the Sherman couldn't be altered. But crews who understood the physics of visibility made better tactical decisions than crews who trusted their armor to protect them. The StuG III continued its devastating career through the end of the war. German records documented over 20,000 confirmed vehicle kills attributed to StuG units by the time Germany surrendered. The total made the StuG the most effective armored fighting vehicle of the entire conflict, measured by enemy vehicles destroyed per unit deployed. The achievement was especially remarkable given the StuG's limitations. Without a rotating turret, the vehicle couldn't engage targets that appeared outside its narrow forward arc. It had to turn its entire hull to aim at flanking enemies, a process that was slower and more dangerous than traversing a turret. In close combat, in urban environments, in any situation where threats came from multiple directions, the StuG was at a severe disadvantage, but armored combat rarely happened in those conditions. Most tank engagements occurred at distance, across open terrain, where the vehicle that spotted the enemy first had a massive advantage. In those conditions, the StuG's low profile wasn't a trade-off. It was an absolute superiority. The Americans learned this lesson again in the hedgerows of Normandy. Sherman crews who had trained with the new doctrine survived longer than crews who hadn't. They learned to approach ridgelines with caution, to use the terrain to mask their silhouette, to assume that any German position might contain an assault gun they couldn't see until it fired. They also learned to fear the distinctive shape of the StuG, In a way, they didn't fear other German vehicles. A Panther or Tiger was terrifying because of its thick armor and powerful gun. A StuG was terrifying because you might not see it until your tank was already burning. The post-war analysis confirmed what the Aberdeen tests had suggested. Tank crews across all nations died most often when they were engaged by enemies they hadn't detected. The quality of armor, the caliber of the gun, the training of the crew, these factors mattered. But they mattered less than the simple question of who saw whom first. The lesson reshaped tank design for the next 50 years. Soviet engineers, who had access to German documents after the war, incorporated low-profile design philosophy into their next generation of armored vehicles. The T-54 and its successors were built with the smallest possible silhouette, sacrificing crew comfort and internal space for reduced visibility. American designers eventually moved in the same direction, though the transition took decades. The StuG III itself was too specialized for post-war use. The limitations of the fixed gun became more problematic as warfare evolved. But the principle it demonstrated, that visibility matters more than protection, became foundational to armored vehicle design. The captured StuG at Aberdeen was eventually moved to a museum, where it sat alongside dozens of other captured vehicles from the war. Visitors walked past it without much attention. It didn't have the imposing presence of a Tiger or the sleek lines of a Panther. It looked like what it was, a low, ugly box with a gun sticking out of the front. But the officers who had supervised the tests remembered. They remembered the moment when they understood that their entire approach to armored warfare had been based on a flawed assumption. They remembered calculating the statistics and realizing that American crews were dying because American tanks were too tall. Sometimes the most important lessons are the ones that seem obvious in retrospect. Of course, a smaller target is harder to hit. Of course, a vehicle that can't be seen has an advantage over a vehicle that can. Of course, visibility matters. But the Americans had built thousands of Shermans before anyone thought to measure these factors scientifically. They had sent crews into combat with vehicles that were easier to spot, easier to hit, and easier to kill than their German counterparts. They had assumed that armor and firepower were the variables that mattered. And they had been wrong. The StuG proved that sometimes it's better to be invisible than invincible. That the most dangerous enemy is the one you don't see until it's too late. That 58 centimeters of height difference, a measurement so small it seems insignificant, can determine who lives and who dies in armored combat. The Germans understood this from the beginning. They built a vehicle that sacrificed the flexibility of a turret for the survivability of a low profile. They accepted the trade-offs because they knew that in most combat situations, the vehicle that fired first would win. The Americans learned it at Aberdeen in 1943. They learned it in the hedgerows of Normandy in 1944. They learned it in the statistics that showed German assault guns destroying Allied armor at rates that seemed impossible given the relative specifications of the vehicles involved. 20,000 enemy vehicles destroyed by StuG units. 20,000 crews who spotted the American or British or Soviet tank before it spotted them. 20,000 first shots fired from a position of advantage that no amount of armor could compensate for. The tests at Aberdeen were supposed to reveal German technological superiority. Instead, they revealed German conceptual superiority. The Germans had understood something about the physics of combat that the Americans were still learning. You can build the strongest tank in the world. You can wrap it in armor that stops every shell the enemy fires. You can mount a gun that destroys anything it hits. But if the enemy sees you first, none of that matters. If the enemy fires before you know they're there, your armor and your gun and your training all become irrelevant. The duel is decided before it begins, determined not by who was stronger, but by who was smaller. 58 centimeters. The difference between a Sherman that died and a StuG that lived. The margin that made an infantry support gun into the most effective tank destroyer in military history. The most dangerous enemy is the one you don't see until it's too late. The Germans knew this in 1937 when they designed the StuG. The Americans learned it in 1943 when they tested one at Aberdeen. And tank designers have remembered it ever since. If this story of invisible versus invincible hit you the way it hit me, Smash that like button right now. Every like tells the algorithm that the physics of warfare deserve to be understood. If you're not subscribed, now is the time, because next week we're uncovering another counterintuitive weapon that proved the experts wrong. Drop a comment and answer honestly. If you were designing a tank, would you prioritize armor thickness or low profile? I want to know. I'll see you in the next one.